Okay, everybody, let's double check to see if this is going through here. Well, okay, it is. It looks like our volume is there. So good morning to all of you guys. Um, yeah, good morning to you guys. I just want to let you guys know I think you guys did very well on that test three. If I had my applause button, I would be applauding and thank you guys for doing as well as you did on your test three. Um, it was a fantastic experience grading that. So I don't know what we did right or what we did wrong, but we did something right. I have no idea. I'm gonna have to go back and take a look so that on test four in the final we can repeat all that, you know? And that's the idea. So congratulations to you guys for doing the job you did on that exam. I don't know, maybe some of the extra credit I did was somewhat helpful. I have no idea. No idea. Um, but anyway, congratulations to you guys. I did send out as an announcement the drop deadline because the department chair sent an email and said, hey, remind all your students. So I did send that out. It's on May 7th. I'm actually going to look something up. I was reading about some things here. I got to look something up really quick. Yada, yada, yada. Just give me a few seconds. And no, that's not what I want to do. Okay, I want to look for a few things. Anyway, that's weird. It's very weird. Bless you. How you doing? Okay. Yeah, I was just trying to check something on SIS. Anyway, all right, folks, let's take a look at what's going on here. Oh, I did want to remind people something here on the website. Now, remember our website here. We have a page here for 241, and we do have some worksheets here. Or not worksheets, video library. For some of these ideas that we go over, if you want to go over and maybe you review extra examples at any time, we have some here in the videos there, right? So you guys have some extra options to look at some, you know, some information. So even on half angle identities, what we do today, you can look over some more additional examples for yourself. And I'm going to put that in or what? Let's put that here. Edit, copy. Um, there we go. Half angle identities there. Okay. So even if we, stuff that we're doing today, even addition and subtraction formulas, all these other express as a single sign, all these things are there for you guys. So I put that there as well. Anyway, okay. Let's see where we're at. Now, if I can find this, no, that's not where I want to go. I want to go to the, let's go back to the browser. We forgot to fire up the iPad. Okay, as I'm reading this here. Now, let's go back a little bit to take a look. Now we can go to iPad. There we go. So let's go back and take a little bit, take a look at some of these identities. If I have it here still, yes, let's take a look at why they call that a half angle identity, okay? But I'm going to write it down. I'm going to write it a little differently. Okay. Let me double check to see your book. Your book wants to write it as, okay, I guess we can do it that way. Whatever. If you take sine squared theta, for example, and we know this is 1/2, okay, 1 minus cosine double theta. Okay, I wrote this down yesterday, but I did a different change of variables. We're going to change the variable here, right? So you say, okay, what do you mean change that variable? Well, that theta here, that variable theta, I'm going to let just x over 2. So I'm going to replace that with x over 2 here, okay? And so that's going to be 1/2, 1 minus cosine 2, not times theta, but x over what? 2. So if you change that theta to x over 2, you're changing this theta here. Okay? Now, you say, what does that give us? Well, that gives us sine squared x over 2 is 1/2 now, 1 minus cosine of x. Okay? So you might say, hey, Mr. Judge, whoever wrote that handout, I would have appreciated if they actually did a little bit of this so that we can understand that this is a what? A half angle. And that's hence the title, Half Angle Identity. All right, you guys understand that? You see my point? However, we're not kind of done with this. And you say, why? Because this is a power of what? What power do you guys see here? 2. I got to figure this out. I think it's, is it the tip? I think I have a newer one. I hate when it's that slow. You see how it's a power of 2? So I want to introduce some algebra to you guys again, right? We already did this, ironically. Anybody remember what this is here? If I say to you, if a squared equals b, this is from some algebra, because this is kind of an S. What does that mean? If a squared is b, then what can I say about a? What does a equal? You guys know? What would a be? Well, it's plus or minus the square root of what? B. All right, you guys okay with that? It's plus or minus the square root of b. Now, what that means here is what happens with that sign, we get plus or minus square root 1/2 1 minus cosine of x, ladies and gentlemen, and there you go. All right, you guys okay with that one? And that's just a reality, I should say, from the identity. So your book doesn't list it this way, but I want to remind people there's 2 possible answers. Okay, there's going to be 2 possible answers. Well, in theory there's 2, but you're going to see how this really works. All right, we're going to look at the all students take calculus. That's going to come into play here. But I just want to share with you guys where some of these identities come from, right? This is the one that we actually use. Well, we use both, but this is the one we actually use here on some of our homework questions, and you're going to see what I'm talking about. But notice again, what's the statement here? This has to be a what? This is a half angle. Okay? All right? So that's the one we use. Now, you might say, well, what about the others? Well, the others have very similar what? If I go back and look at, for example, cosine squared, we could do the same kind of thing. Since cosine squared theta now equals what? 1/2 1. Now this is plus cosine what? Double theta. We're going to replace again theta with a half angle, just x over 2. We're just going to change the variable. We can use any letter we like. And when you do that, notice what you end up with. You'll have cosine squared x over 2 is 1/2 1 plus cosine 2 x over 2. And so I have cosine squared x over 2 is 1/2 1 plus cosine x. So using the algebra, what do we say now here? What do we get again? Plus or minus square root. What's this? 1/2 1 plus cosine of x, ladies and gentlemen. All right. And so again, this is going to be the version that we end up using. And I think I'm going to use a highlighter. Okay. I'm going to use a highlighter here on this one. So that's the one we end up using here. All right, good. All right, now, ladies and gentlemen, you say, what about this, the next one here, because we have these others here. What about tangent squared theta? We proved was 1 minus cosine double theta over 1 plus cosine of what? Double theta. Okay, and so notice what we're going to do. We're going to do the same change of variables. You say, what's the change of variables here, right? You're going to let theta be x over 2 again. So since we have theta in 2 places, we get tangent squared. That'll be x over 2 is 1 minus cosine 2 times x over 2 over 1 plus cosine 2 times x over 2. Okay, so you get your tangent squared again. This is the half angle. And then that's 1 minus cosine just x. 1 plus cosine x. Okay, now you say, well, what do we do with this? Well, the same kind of thing we're doing here. So that cosine, I'm sorry, tangent, we're doing tangent. So tangent x over 2 would become plus or minus square root 1 minus cosine x over 1 plus cosine of x. Okay. Now I'm going to do a little bit of algebra because we're going to do a little bit of simplification here. So let's go back to some algebra here. Let's talk about this here. All right. So from algebra, I want to remind people of some of these ideas. Let's do some of the yes here. Do you guys remember that conjugate kind of? Well, there's something called conjugate-ish, I guess. This really isn't, I should say, conjugates, though, in a technical way, right? This isn't like an intermediate algebra. You do have this idea of a conjugate. So let's spend some time with that. Square root of A plus square root of B, square root of A times square root of B. So going back to some intermediate algebra, if you use FOIL on this, we got a nice what? A minus B. Okay. And then you might say to me, but Mr. Judge, that's technically an intermediate algebra conjugate situation, right? That's irrational conjugates. You also had complex conjugates. Okay, so I'm going to spend some S time today. Complex conjugates. And that's done by FOIL as well, using FOIL. So there's the algebra portion here. And then even in intermediate algebra, right, even in that particular course, you got these two types of conjugates, right? You got irrational conjugates, and then what I say to students sometimes is you see some things that are conjugate-ish. These are technically the conjugate situations. So you got conjugate-ish. They're really not technically conjugates. Right? When you multiply conjugates, something special happens by FOIL. So conjugate-ish, ladies and gentlemen. Here's the thing. You know, you can have 1 plus like the square root of, or let's do it this way. Sometimes it happens in that course, intermediate algebra. You got A plus the square root of B, right? And then you have A minus the square root of B. This is not a conjugate situation. And you say, why is that not conjugates? You guys remember from intermediate algebra? Why isn't that conjugates? Right? Why aren't they? These are irrational. The first one is irrational conjugates. The second one is complex conjugates. So why aren't these irrational conjugates by definition? Right? Because the first part here, let's find a nice color. The first part over here is missing the square root. Is that right? So they're not technically conjugates because it's missing the square root. What do you get by FOIL? What's the first term? A squared. And then the O and I terms go away. Is that right? And then the last term is going to be, this is minus B squared, by the way. I'm sorry, minus B. Because when you multiply square root of B, that's just B, right? So I want you guys to even note that from algebra, just in case you said, hey, Mr. Judge, I forgot this. Okay, just so you guys remember this, right? Isn't that going to be just B? So just looking at a little S, looking at a little algebra here, you know, some of these ideas. Okay, you guys okay with that one? That's what I call conjugate-ish. So you see a bunch of those all the time. You know, like kind of a quick example, if I went back to intermediate algebra, you know, you gave students questions that look like this maybe. Right? You ask them to multiply. Well, that's going to be the 1 squared minus 3, which is 1 minus 3, which is equal to what? Negative 2. You know, that kind of stuff. If you guys remember from algebra, working with conjugates, right? Well, you might say, what does that have to do with what we're working with here? Well, whether we like it or not, I'm actually this morning reading a nice paper on, so you go, what's going on with you? I got a remark by noon on this paper. It's actually exactly the topic that we have here, you know. I won't go into those details. I don't want to open that up. Copy. So you say, what are you talking about here? So ladies and gentlemen, we're going to do some simplification of this identity here. All right? We're going to take a closer look. We're going to do a deeper dive. You go, what's the deeper dive here? 1 plus cosine. So you guys ready for a little bit of logic, a little bit of math logic? This is good stuff. You guys see this here? I'm going to take a fraction and I'm going to multiply it times the number 1. Doesn't that not change the fraction? What I'm saying here is under the radical here, right? I have all this under the radical. If I multiply that fraction by 1, it doesn't change it. Is that right? Also, this is the whole point. One minus cosine x, 1 plus cosine x, right? Isn't it true that anything divided by itself is actually 1 by some more algebra or arithmetic even? You guys with me on that idea? All right. Now, you know what's it's amazing here about this? I can actually put anything in that triangle, anything I want. I mean, you don't just put anything, but I can. It doesn't matter what I put in there, right? It doesn't matter. So what I'm going to put in here is this right now. 1 minus cosine x and 1 minus cosine x. Okay, because that number is 1. Is that true? Do you guys know what I'm saying? That number is 1. All right, so here's what happens. 1 minus cosine. 1 minus cosine, okay? And this is all over 1 plus cosine times what? 1 plus cosine. Now here is the fun, ladies and gentlemen. Okay, this is 1 minus cosine to the second power. All right, because we're going to look at some algebra again. You go, what's the algebra? Well, a times a is a to the what? Second power. Remember, I like to put my algebra in purple here. So that's my numerator for 1 minus cosine times 1 minus cosine. This is why I say 1 minus cosine squared. You guys okay with the numerator? Yes.
Where the middle radical on the right side, the conjugate, should it be 1 minus cosine instead of plus cosine?
Did I write down? No. Well, did I make a mistake? Oh, this one's a negative. I see what you're saying. Sorry. Thank you for being awake. I'm thinking of my response on my paper. It's not my paper. Thank you. There you go. All right. And then you might say, oh, Mr. Judge, down here, isn't that conjugate-ish? Because it's technically not one of these what? Conjugates, right? This is a conjugate. This conjugate is a technical term, but this is why I use the informal conjugate-ish, you know, because it's kind of like a conjugate. It's not really a conjugate, but it's kind of like it. And so that gives us now by FOIL 1 squared minus what? Cosine squared. Right? That's the whole idea. And 1 squared minus cosine squared, you guys know what that is. What is that going to be? 1 squared minus cosine squared is what? Yep. Sine squared. Okay. So that's just a nice sine squared. All righty. Now, okay. is this? All righty. Now, here's what you guys want to know. I'm going to do some more algebra. And I'm going to say the square. This is kind of what you guys want to see, algebraically speaking here, okay? You guys see what I'm saying? You got the square root of a squared over b squared. Well, the square root of a quotient is quotient of square roots. So you might say, can I write this here now as what? Plus or minus square root 1 minus cosine of x squared over square root of sine squared. Yes. And then I want you guys to know as well, if you're taking the pre-calculus course, you guys should know what this is. Anybody here taking the pre-calculus course? What's the square root of a squared? That's the absolute value of a. All right, absolute value of a. Now, if we're going to say to you guys, ooh, we're going to get even more deeper, because what you're looking at here is the absolute value of 1 minus cosine over the absolute value of what? Sine. Okay, you guys okay with that one? Now, what's the meaning of absolute value? There's a meaning of absolute value. The absolute value is defined to be a by itself. You could get rid of it if a is greater than or equal to 0. It is opposite a if a is less than 0. So you got tangent x over 2 is plus or minus what? Well, we know something here. We have the denominator being absolute value of sine. However, here's what you guys know about 1 minus cosine. 1 minus cosine is greater than or equal to 0. Okay, so I want you guys to know that 1 minus cosine will always be greater than or equal to 0. So you write this as 1 minus cosine. So it's always going to be positive. No, it's actually because cosine, it's not because of even. It's because, if you guys remember, cosine is between what? Positive 1 and negative 1. And then what I'm going to share with you guys is this, because you go, okay, I got my absolute value here. Here's what you guys don't know yet, but here's what's going to happen. All righty. Sine and tangent. So this thing will always have the same sign. So they're either both positive or both negative. Okay? And so what that leaves us with now, if we look at, and I'm looking at it here in our book, this thing. This is what your book has as a final representation of this. Your book has, really your book has this. It's going to have, what does it have there? You're going to have 1 minus cosine over sine. However, it says the choice of plus or minus depends on the quadrant. So the choice of plus or minus depends on the quadrant the half angle lives. And we're going to see an example of how to use these here. So this is kind of where they come from. So your book has these formulas there. So I just want to go through that. So if you look at that and you go, oh, okay, what's the deal with these here, right? So let's look at some examples of something like this, right? So if they said to you, what's cosine now of 22.5 degrees? Right? So you say, what's cosine at 22.5 degrees? Maybe. Well, what did we just derive for cosine? Anybody? Where's cosine? See this here? Okay. So what do you think we're going to have to what are we going to have to do, right? This is all based on writing this as a half angle. Okay, that as a half angle. So 22.5 degrees, what do you guys know about that? Isn't that 45 degrees divided by 2? Is that right? And so this is going to be plus or minus square root 1/2 1 plus cosine of what? What do I put in there? Can you guys see that there? Let me put a color here. That has to be what? 45 degrees. Okay, you guys okay with that? Is that 45 degrees? Now, notice this though. We have to say something about this plus or minus though. And I'm going to put this in black. Which quadrant is 22.5 degrees in? This is in quadrant what? 1. Is that true? Isn't 22.5 degrees in quadrant 1? What does that mean if it's in quadrant 1 then? Okay, let me go back here. This is what I want you guys to remember here. Okay, this is kind of why you do some of these exercises. All students take what? Calculus. Where is this in? What do you guys know? What is the meaning of A? A is what? All 3 are positive. What do you think that means then? That means that this will be positive. So you remember it's plus or minus, but you're going to have to make that determination, right? It's plus or minus. So if it's plus or minus, you go, has to be plus. It's not minus. Yes?
So wait, because it's cosine of 45 over 2. So what would we consider x
where you're looking where 22.5 is the half angle. So the half angle is 22. So cosine is in quadrant. Cosine at 22.5 is in quadrant 1. Because 22.5, that's quadrant 1. So all of them are positive, which means cosine's positive. If the angle was in quadrant 2, cosine will be what? Negative. Because in quadrant 2, well, that's S. S is positive. So that's the determination you have to make. What's the other determination? What's the other thing you have to know? Cosine 45 degrees is what? Isn't that the square root of 2 over 2? Okay, you guys with me on that? So the other thing you have to remember is that, I'm going to use a different color, is this is square root of 2 over 2. So you have 1/2 square root, 1/2, 1 plus square root of 2 over 2. Now, what do you guys want to do with this? Now we're going to have to do some more arithmetic here. Okay, we're going to have to simplify this. I'm going to say here, focus right here. We're going to have to add. Okay, so we're going to add here. See that 2? This will be what? 2 over 2. Okay. You get the square root of 1/2. 2 plus the square root of 2 over 2. Okay. Now, can I factor out that 2? So this is now going to be 1/4, 2 plus the square root of 2. And more properties of radicals, okay? Do you guys know that if you have the square root of a product, that's product of what? Square roots. There's your algebra. Square root of 1/4 times square root of 2 plus square root of 2. Now, the square root of 1/4, ladies and gentlemen, is what? Is 1/2. And so if you look in any trig book, I want you guys to be aware that this here is what you'll see. Okay, that's 2 plus square root of 2 over 2. And this is called a nested radical, where you got the square root inside a square root. These are rational numbers. So as you guys can see, there's all this algebra here that exists, and you know that, ooh, I don't know, something's wrong there. That exists in evaluating that, and so that's how you use some of these identities. But there's a couple of things to kind of remember here, right? What quadrant is the angle in? All students take calculus. This is what we're going to do a deeper dive for a couple of weeks. All students take calculus because the angle of 22.5 degrees is in quadrant what? Quadrant 1. I'm not, that's actually not exactly it, but that looks more like 45. 22.5. Compare that to, ladies and gentlemen, if they said, what is tangent of now 15 degrees? So how do we write 15 degrees as a half angle? What do you guys think? Isn't this what? Isn't that 30 degrees over 2? Isn't that going to be 15 degrees? You guys okay with that one? So they're saying, oh, I need to do 30 degrees divided by 2. Now, I think in your book, what did I just give you guys? The identity that I showed you, because there's actually two. It's 1 minus cosine now, 30 degrees, over sine of what? 30 degrees. What do you guys know about the angle 15 degrees? What quadrant is that in? Isn't that in quadrant 1 again? So that tangent's going to be positive. So what does this mean? Do I know what's cosine 30 degrees? If you don't know, can I share with you guys a little secret? I don't go to bed at night knowing cosine 30 degrees. When I go to bed, I know this. Special triangle. This is the 30-degree angle they're talking about, right? So what's cosine 30 degrees? Anybody want to tell me? I need to know cosine 30 and sine 30. What do you guys think? What's this going to be? What's cosine 30? Yeah, square root of 3 over 2. Thank you. That's right. What's sine 30? Anybody know? Is that 1/2? Double check I'm not awake yet. See if I still have any more coffee. So what do? I'm going to say I put this where? This is going to be what? Cosine 30 goes right here. Is that right? Where does sine 30 go? Right there. So it's 1 minus the square root of 3 over 2 divided by 1/2. And that's 1 minus the square root of 3 over 2. I have to do my arithmetic this way, ladies and gentlemen. A whole number, and then you know what I have to do? I have to flip that over and say 2 over 1. And so what does this give me? 2 minus what? Square root of 3. Double check to see if I'm awake on this one. Is that right? Did I do the right arithmetic? Double check my arithmetic, ladies and gentlemen. I'm not really awake. Is there a radical 3 over 5? 2. 1 minus. Yeah, where did that come from? What's that? I plugged it in. Plugged it in. Plugged it in, ladies and gentlemen. There you go. What do you guys think? Not too bad. It is arithmetic. Here's your final answer. So they're going to want us to know how to do some of these here. What if we had something like this, for example, sine of what? Sine of 75 degrees, maybe now. And we have to use half angle. Right? We're using half angle here. What do I replace 75 degrees with if it's half angle? Should we do 75? Anybody know? Like on your test, isn't that going to be what? I think we're using red, right? How do I write that as a half angle, 75? Isn't that what? 150 over 2? Is that true? So I have sine of 150 over 2. Now, what is that? Do you guys remember? Plus or minus square root Plus or minus square root of what? We did cosine, we did tangent, we did sine. All right, where is this sine? Square root 1/2 1 minus cosine. Okay. It's the 1 minus cosine, right? And that's cosine 150, right? Now, what do you guys know about 75 degrees? Where does 75 degrees live, right? Because we have to find what sign to use, right? Because we have to look at the half angle. All students take calculus. So where does 150, or I'm sorry, 75 live? That's still quadrant 1? Okay. So what does that mean? Because that's in quadrant 1. That's half angle, 75 degrees. That's a quadrant 1 angle, right? So that means the answer should be what? Positive or negative? Positive. Is that right, ladies and gentlemen? But you have to know where cosine of 150 degrees is. And 150, I think 150 is over here. Is that right? All students, that's quadrant 2. So don't we look for what? The reference angle, 30 degrees. Do you guys remember that? So I need to have knowledge of cosine of 30 degrees, the reference angle. So I'm going to put that in purple. That's my special triangle. Cosine 30. Where do I go? What's cosine 30 if I go back here? Oh, we already know it's what? Square root of 3 over 2. Isn't that right here? Well, we already deduced this. We use that. But what does that mean about cosine of 150? That may be great. That's cosine of the reference. That means cosine 150. Well, what's going on in quadrant 2? All students take calculus. That's S. What does that mean about 150 and cosine? Anybody want to tell me? You guys did well in that test. You should know how to do this. What does that mean? You guys are looking at, it's negative. Is that true? Good job. Look at that, ladies and gentlemen. Oh my God. Yes, it's negative. Okay, you guys okay with that? And I'm going to kind of use a color here because I want you guys to see we're going to substitute that answer right in here. And be careful, okay? Because that's going to equal 1/2 1 minus a negative square root of 3 over 2. And what is that, ladies and gentlemen? Do you guys know? Isn't that 1/2 what? 1 plus a square root of 3 over 2. So you guys know. Because minus a minus makes this a what? A plus. And then again, you do the same arithmetic. You go, what arithmetic do I do? Well, replace 1 with 2 over 2. So you get 1/2 now. 2 plus the square root of 3 over 2. Factor out the 2, so that's 1/4. 2 plus the square root of 3. Again, use the property that the square root of a product is product of square roots, ladies and gentlemen. And then you get now 1/2 2 plus the square root of 3. And you look in the back of the book, you say, oh, that's 2 plus square root of 3, everything over 2. And you go, that's a weird answer. I've never seen answers square roots within square roots. Yep. Nested. It's called nested radicals. Nested radicals. Yeah.
So our whole equation, when we get sine of 75 is equal to plus or minus 1/2 minus the cosine of minus or plus radical 3/2. Should our whole radical be positive or negative?
Well, go back to this. You have a good question. Remember how you have this statement here in your formula, right? You go, Mr. Judge, they gave me plus or minus. How do I, excuse me, how do I know if it's positive or negative? How do you guys know? You're going to have to know what quadrant 75 degrees is. I think I wrote it down. I thought I wrote it down. What quadrant is this angle in? Yeah. Okay. So what do you guys know about sine in quadrant 1? Yep. So that's what you do. That's why I erased it. Mm-hmm.
And then for tangent, it depends on if it comes out positive or negative.
Well, it's all going to be the same idea. It's the same idea. What quadrant it lies in. In fact, I think with tangent, you're just going to follow that strict formula. And there's actually two. If you look in your book, I didn't. Maybe we'll go back. And your book doesn't prove it. Your book proves the first one, and it gives you the same arguments about it, but it's really the same thing. And I'm going to change this one here so that if you guys want to look back at some of those, you'll see something a little bit different, right? You have videos for half angle as well. So if you want to see additional examples. And here, what is this going to be? What half angle is this? Because this is going to be different now. So I want to share with you guys why this is different. Maybe I should do cosine. Maybe I should do cosine. Maybe this is going to be a good example so you guys see the difference. I want you guys to see it. No, I could do sine. I apologize. What angle is that? Do you guys know? As a half angle, what would you guys do? Is it 225? You guys okay with that one? Sine of what? Okay. So what was this going to be? Plus or minus square root of what? Wasn't this what? 1/2. 1/2. Is it plus or is it minus? That's minus. Is that right? Cosine of 225. But what do you guys have to know, right? This is going to be important here. This is essentially the question that was asked. Is it positive or is it negative? Well, I don't know. Let me go back to find out. Where's this angle? All students take what? Calculus. Where's the angle 112.5 degrees in? Isn't that 112.5? Isn't that in quadrant what, 2? So what do you guys know? Sine is positive. Is that right? What if this was cosine like I tried to change it to? Negative. Outstanding. That's what you guys want to do. So it's going to be positive again. I wanted to do a negative, but whatever. But you're going to have to know about cosine 225. All right. Well, where's 225 in? What quadrant is that in? Is this 225 maybe? Do you guys know what I'm saying? Because you need to tell me what cosine of 225 would be. Is that in quadrant 3? Because I'm not awake. I think 180. What's the reference angle? Good job. That is so important to know. That is everything, ladies and gentlemen, right here. Getting that reference angle, because if you guys remember, cosine 45 degrees, it's another special triangle. That's square root of 2 over 2. So I can replace this with the square root of 2 over 2. Oops, sorry. Not necessarily. Let me go back. I don't know. What's cosine 225 degrees then? Is it positive or is it negative? What? Yeah, 225 is in what quadrant? It's in 3. Tangent's positive, but that means what? Cosine is what? Negative. Yeah, so that's a negative square root of 2 over 2. Okay? So you got the square root, 1/2, 1 minus a minus square root of 2 over 2. And you get 1/2, 1 plus the square root of 2 over 2. And so what do you replace that with, right? That 1. Replace with 2 over 2. So all the arithmetic, as you guys can see, is very similar, right? 2 plus the square root of 2 over 2, it looks like, right? Double check. 1/4, looks like it's 2 plus the square root of 2. Okay? Square root of 1/4, square root of 2 plus square root of 2. What's the square root of 1/4? 1/2. 2 plus square root of 2. So final answer, again, nested radicals. Let's try tangent here. 5 pi over 12. What do you guys think about this one? What do you guys think about this? 5 pi over 12. What do you guys think? What did we do before? I mean, there's a couple of things we could do, right? Did we do that one already? Check our notes. Five pi over 12 is really what? Right? So if you're at home, you go, what'd you just do, Mr. Judge? 5 times 180 divided by 12. Do you guys know what that is? 75 degrees. Is that right? So did we do tangent of 75 already? What do you guys think? Did we do that one? No? Sine. Okay. We'll try tangent. No big deal. So what do we replace this with? No, we figured out, we converted 5 pi over 12 to degrees. So you're going to write this as 150 over what? 2. 150 over 2. Okay, now if I kind of, let's go back. Let's try to find it here. What am I talking about here? Where are we? Oh, I think it was formula sheet, right? Trig cheat sheet. No, do I have it here? Oh, I don't think do they have it? I don't think they have it. It's in the book. Let's see. Yeah, they don't have it. Anyway. Okay. So it's not in that trig cheat sheet. All right. So what did we just get through saying? That was going to be, when we just got through talking about, this is 1 minus cosine of what? 150 divided by what? Sine of 150. Is that true? Do you guys remember? I'm going to change that color. Let's double check to see what our answer is going to be, right? $75. Well, it doesn't look like that. It looks more like this. Isn't this where 75 degrees would be? Quadrant 1. All students take calculus. So, okay. But in order to answer this question, I got to know where 150 is. So I'm going to say this here is 150. More importantly, though, what's the reference? 30 degrees. So I need to know really what sine 30 is and what cosine 30 is. Right? And I thought I have it up here. Yeah. Cosine 30 is square root of 3 over 2. Sine 30 is 1/2. All right, cosine 30 square root of 3 over 2. Sine is 1/2. Thought it was familiar. Okay. But what does that mean about cosine 150 now? Right, cosine 150 is going to be, well, quadrant 2, sine is positive, cosine is negative. So if I want to color coordinate this again, orange and then green. Sometimes that's pretty helpful, right? So orange, let's get rid of that. Orange and green. Square root of 3 over 2. So what do we get? And wasn't one's negative? It's supposed to be negative, right? So you get 1 minus a negative square root of 3 over 2 divided by 1/2. What does that give you? 1 plus the square root of 3 over 2 divided by 1/2. I always have to write it, ladies and gentlemen, let me tell you guys, this way. Meaning, if I'm ever going to divide by a fraction, I write it that way. Then I multiply by the reciprocal. And when you multiply, what happens? This is 2 plus what? Square root of 3. Yeah. I did what? What did I do? It's, yeah, 1 minus a minus makes it a 1 plus. Yeah. Anyway, there you go. No. What's the formula that we used? You guys see what I'm saying? Let's go over here. Was this tangent? You might say, Mr. Judge, I have 2 formulas for tangent. Why do I use this one? Because your book has a second formula for tangent. But why would I use this one? You guys know why I use this one? So I don't have to rationalize the denominator. If I use sine over 1 plus cosine, the alternate version that the book doesn't even prove, the one the book doesn't prove, you'd have to rationalize the denominator. So notice for every time I have tangent, I never rationalize the denominator. It's this nice, beautiful relationship. And some of your calculators, by the way, if you plug it in like this symbolically, they'll give you that answer, like 2 plus the square root of 3 in your calculator. And you go, where did that even come from? So some of your calculators give these answers this way symbolically. And you might say, I don't know where that comes from. Well, now you guys know where it comes from. It comes from these identities. And then you have the whole kind of, questions that look like this. I don't know if I want to do those. Like what happens when you have, yeah. I mean, I don't know. I guess we can try. No, let's try some more of these here. I'm not going to do that. Sine of negative 11 pi over what? 12. What do you guys know about sine of a negative angle? Is that negative sine of what? 11 pi over 12? Is that true? I can pull out that negative sign. So let's just be careful, okay? So what am I going to do here? I'm going to convert. Remember that? What is pi really? 11 times 180 divided by what? 12. Is that right? 165 degrees. Negative sine, 165 degrees. What I'm going to suggest you guys do, this is all about half angle, right? What is this going to be as a half angle? Is that 330? Isn't this 330 degrees divided by 2, I think? Is that right? I'm kind of waking up. Minus sine 330 degrees divided by 2. Let me kind of give you guys a recommendation on this here. Right? Find the positive angle. Here's what I mean. I know that's minus, but when you use the identity, you're going to have to use what? What is this identity going to be? For this portion, let me write it that way, right? Isn't that identity plus or minus square root 1/2 1 minus cosine of 330 degrees? Double check. but we have to know where 165 degrees lives. Is that right? 165. Because that's the half angle, 165. Quadrant 1, quadrant 2, quadrant 3, quadrant 4, all students take calculus. Where is 165? Quadrant 2? That's a quadrant 2 angle. What do you know about sine in quadrant 2? Sine is what? Isn't it positive? Okay, you guys okay with that? Sine's positive? All right, where's 330 at? Yep. So here's 330, ladies and gentlemen. And more importantly, you need the reference angle. Is that right? What's your reference angle? 30. So we know cosine of 30. What's cosine 30? Is that square root of 3 over 2? I think I'm memorizing it by now. So that means cosine of 330. What's cosine 330 then? We want to use blue. What do you guys know about that one? Oh, it's positive because it's in, where's 330 in? All students take what? Calculus. That means it's also positive. Is that right? So you go, oh, okay. I get to replace my cosine with positive square root of 3 over 2. So that's going to give us 1/2 1 minus square root of 3 over 2. So we're going to do the same arithmetic over and over. 2 over 2. One half, say, is that 2 minus the square root of 3 over 2? That gives me now square root of 1/4. 2 minus the square root of 3. Is that right? And then you guys know by now, what's that going to give us? Square root of 2 minus the square root of 3, everything over 2. Now, be careful, though. Be careful. Why do I say be careful? What do we have to remember? They gave us sine of a negative angle. What did you guys have to do? You had to pull out the what? That negative sign to begin with. Do you guys remember that? Because sine was what? Odd. So what do we have to do at the very end? Put the what? Put that negative sign. Just want to point that out to you guys. Okay, just wanted to point that out anyway. So in Canvas, homework number 4. I'm going to change this to 26 now. Okay, because we worked on some of those half angles. Try some of those out. Okay, and now pass back your guys' exams. Again, congratulations. Okay, I'm going to pass those things back to you guys. And we'll see you guys tomorrow.